Cross validation in machine learning is the sixth topic in the third unit of artificial intelligence and machine learning. It is a technique used in machine learning to evaluate the performance of the model on unseen data. It involves dividing the available data into multiple folds or subsets using one of these folds as a validation set and training the model on the remaining folds. This process is repeated multiple times, each time using a different fold as the validation set. Finally, the results from each validation step are averaged to produce a more robust estimate of the model's performance. It is an important step in the machine learning process and helps to ensure the model selected for deployment is robust and generalizes well to new data. Where it is used for. The main purpose of cross validation is prevent overfitting, which occurs when a model is trained too well on a training data and performs poorly on new unseen data. By evaluating the model on multiple validation sets, cross validation provides a more realistic estimate of the model's generalization performance. That is, its ability to perform well on new unseen data. There are varieties of types of cross validations are there. One is holdover validation. In this validation, the training on the 50% of the given data set and the rest 50% is used to test the testing purpose. Second one is leave one out cross validation. In this, the model trained on the n-1 samples and tested on the one omitted sample. Repeating this process for each data point in the data set, it has some advantages as well as disadvantages. Advantage of LOOCV cross validation is using this method we can make use of all the data points and then it is low bias. The drawback is it leads to higher variation in the testing model as we are testing against one data point. The third type is stratified cross validation. It is a technique used in machine learning to ensure that each fold of the cross validation process maintains the same data class distribution as the entire data set. It is important when dealing with imbalanced data sets where certain classes may be underrepresented. The data set is divided into k folds while maintaining the proportion of classes in each fold. During each iteration, one fold is used for testing and remaining folds are used for training. K-fold cross validation. In K-fold cross validation, we split the dataset into k number of subsets known as folds, where we perform training on all of the subsets and leave one k-1 subset for the evaluation of the training model.